Okay, go ahead, take a look in the mirror. Seriously, what color are your eyes? Brown, blue, green? Well, that color staring back at you, it isn't just some random physical trait. Nope, it's actually the final chapter of this incredible journey. Hidden in your eyes is a wild story about human migration, survival, and one single genetic accident that changed everything.
I mean, what if I told you that every single person with blue eyes today, whether they're from Finland or Iran, can trace that trait back to one single common ancestor? One person, someone who lives somewhere around the Black Sea about 10,000 years ago. That's where our story really begins.
You see, before this one individual came along, the story of human eye color was, well, really simple. For pretty much our entire history as a species, there was only one option on the menu.
For almost 300,000 years, every single human on planet Earth had brown eyes. And for good reason. It was a critical survival tool. You've got this pigment called melanin, right? It's packed into the iris and basically acts like built-in sunglasses, protecting our eyes from harsh UV light, especially near the equator. Then, just 10,000 years ago, which is like a blink of an eye in evolutionary time, one little mutation happened. And from that one tiny change, the entire rainbow of eye colors we see today started to emerge. But here's the first big twist in the story. The mutation that gave us blue eyes didn't actually add a new color. It took something away. There is no blue pigment, none, in a blue iris. The color you're seeing is basically just a trick of the light. It's a beautiful optical illusion. And that illusion, that trick of the light, is at the very heart of a massive genetic mystery. How did it even happen? And maybe more importantly, why did a trait that gave us zero obvious survival benefits spread across the planet like wildfire? This is where we put on our detective hats. The physics behind blue eyes is actually the exact same reason the sky looks blue. It's an effect called light scattering. So when light enters an iris that has very little melanin, the shorter blue wavelengths of light just get bounced around and reflected back out. So get this, what we think of as blue isn't a color at all. It's just the absence of the brown pigment melanin. So how does this work genetically? Well, the easiest way to picture it is like a dimmer switch for a light. You have a gene called OCA2, and its job is to crank out melanin. But right next to it is another gene, HERC2, and it acts like the switch that controls OCA2. Now, that ancient mutation, it didn't break the melanin gene itself. It just messed with the HERC2 switch, turning melanin production way down. And this is the part that had scientists scratching their heads for years. Okay, so the mutation is recessive, right? Which means you need to get it from both parents. And on top of that, it arguably makes your eyes more sensitive to light. So genetically speaking, it should have just stayed super rare. So why on earth did it explode across Europe in just a few thousand years? Well, the answer seems to be this powerful 1-2 punch. A combination of two major forces. One part raw survival, and one part, well, seduction. Scientists basically landed on two main theories to explain this. The first is that the gene for blue eyes just happened to be in the right place at the right time, and it hitchhiked along with another, much more important survival gene. The second idea is that in a world where everyone had brown eyes, this new rare trait was just really attractive. Here's how that probably went down. As humans moved north into Europe, they needed lighter skin to soak up enough sunlight to make vitamin D. The genes for light skin were a huge advantage and got selected for really strongly. And since the gene for blue eyes is physically located right next to those skin genes, it often got dragged along for the ride. That's genetic hitchhiking. But that probably wasn't enough on its own. The second force was sexual selection. Think about it. A rare, striking trait like blue eyes would have made you stand out. It's kind of like fashion today. Rarity makes something valuable, and that might have made those individuals more memorable, more desirable partners. But of course, the story doesn't just end with blue eyes. That one little mutation basically kicked the door open for a whole spectrum of other colors to show up. And each one tells a slightly different story about our shared family tree. And when we look at how eye colors are spread out today, you can really see how diverse we've become. Brown eyes are still the clear majority worldwide, at almost 80%. But other colors have definitely carved out their niche. And would you look at that? Green eyes, found in only about 2% of the world's population. That actually makes them the rarest major eye color of all. Now, green and hazel eyes aren't as simple as mixing blue and brown paint. They represent totally different genetic setups, with just a moderate amount of melanin.
And the fact that they're most common in populations with mixed ancestry, well, that paints a really vivid picture of our ancestors migrating, meeting, and mixing it up all across the globe. Okay, so let's bring this all back to you. Right now, what does all this history actually mean? Well, your eye color is like a living clue, and it points right back to the specific journeys your ancestors took thousands of years ago. And you can see just how specific those paths were. I mean, look at this. The blue eye mutation is really common across Northern Europe, but its frequency is all over the place. It's in nearly 90% of people in Finland, but less than half of the people in the UK. These patterns are literally a genetic fingerprint of ancient migrations and how populations mixed over time. Now, I'm sure you remember those Punnett squares from high school biology, right? The little charts that suggested two blue-eyed parents can only have blue-eyed kids. Well, I hate to break it to you, but that neat and tidy little model, yeah, it's wrong. The reality is so much more complicated. In fact, scientists have now identified, get ready for this, more than 16 different genes that all play a role in determining your final eye color. It's not one gene, but a whole team of genes interacting, which is why, on rare occasions, two blue-eyed parents absolutely can have a brown-eyed child. So look, while it's definitely not a simple A plus B equals C situation, your eye color can still offer some really powerful clues about your more recent family history. Blue eyes almost always point back to that single ancestor and a Northern or Eastern European heritage. Green often points to mixed Northern European roots, especially Celtic. And hazel, that often suggests a beautiful blend of European, Mediterranean, or even Middle Eastern ancestry.
So what are the big things to take away from all this? I think it boils down to three crucial points. First, your eye color is a direct, visible link to a specific chapter in our collective human story. Second, evolution is never just about survival of the fittest. It's this messy, fascinating mix of survival, attraction, and pure random chance. And finally, and this might be the most important one, a trait like eye color shows just how superficial our differences really are. They reflect our recent diversity, sure, but underneath it all, we share a much, much deeper connection.
And that leaves us with one last big idea to chew on. The very same genetics that explains the color of your eyes also proves that we are all, without a doubt, part of one human family. We've only recently diversified, and we're all profoundly connected by this shared journey. So the real question isn't what your eye color says about you, it's what are we, together, going to do with that knowledge?